All right, welcome to the video for SPSS Assignment 10, Psych 3010. So we're going to be doing a chi-square analysis, chi-square test for independence today. All right, so if you haven't already, open up SPSS Assignment 10, and that's in Chapter 15 in Unit 4 under Course Content. And here we have the example. So we have women who have just had a baby, and we're looking at their levels of depression compared to before they had the baby. Are they less depressed than before they had the baby, more depressed, or are they about the same? And we want to know whether this is impacted by if this is their first baby or if they've had a baby before. So if you look at the matrix that's presented here on the SPSS assignment, we have the data presented in 2 rows, has had a baby before and first baby, and we have 3 columns, less depressed, about the same, and more depressed. And that becomes a little bit more important when it comes to interpreting our results, to calculating our degrees of freedom. And then if you were doing a hand computation, it's especially important to organize the data in this way. And what we have in each of those cells is just the frequencies. And these are our actual observed frequencies that we see in our data set. So we had, among the women who have had a baby before, 9 of them were less depressed than before having the baby. 24 of them were about the same, and 4 were more depressed. Whereas among those who were having their first baby, 6 were less depressed, 7 were about the same, and 10 were more depressed. We're going to use the chi-square test for independence to determine whether or not those differences based on whether they've had a baby before or not are significant. Okay? So, if you haven't, go ahead and copy your 6 steps over into Word. And we'll start working on step 1. So here's my Word document. Step 1, we're going to come up with question of interest and prediction. So in the question of interest, again, like usual, it doesn't really matter whether we word this, in some specific format or just in the way that makes sense in our heads. So what I'm going to say for my question of interest is there a difference between first-time mothers and those who've had a baby before in their levels of postpartum depression? Okay? And then I need to make a prediction. You can predict whatever makes sense to you. You don't have to predict the same thing that I'm predicting. What I'm going to predict is that mothers who have had children before will be more depressed because they have more things on their plate. They might have, a baby to take care of, but they still also have a toddler or another kid or maybe several to take care of. So I predict that mothers who have had a baby before will have higher levels of postpartum depression. Now, you can predict the opposite. You can predict that first-time mothers will have more depression, or you can predict they'll be about the same. Doesn't matter to me. All right, so once we set up our step 1, question of interest and prediction, we're ready to move on to our hypotheses in step 2. The null hypothesis, like always, is going to state something along the lines of that nothing is going on. When it comes to chi-square, the way that we talk about this in our null and alternative hypothesis is in terms of the relationship between these 2 variables, whether they're related to one another or not. So for the null hypothesis, what I'm going to say is there is no relationship between having children before or not, and levels of depression postpartum. The alternative hypothesis says the exact opposite, that there is a relationship. I'm just going to copy that, paste it, and change it to say there is a relationship between having children before or not and levels of depression postpartum. Pretty simple. We have been told, we're ready to move on to step 3. We have been told in the assignment that the alpha level we should use is 0.05. And anytime we haven't been told, we're going to go ahead and choose an alpha level of 0.05. So I'm going to go ahead and select that now. The next thing we need to do is find our critical value. And in order to find that critical value, we need to find degrees of freedom. The formula for degrees of freedom for chi-square is the number of rows minus 1 times the number of columns minus 1. That's where we want to look back at that matrix that we had in our assignment example. So we had 2 rows, has had a baby versus first baby, and we had 3 columns, less depressed, about the same, and more depressed. So I have 2 minus 1 for 2 rows minus 1, and 3 minus 1 for 3 columns minus 1. That's going to give me 1 times 2, which is 2. So our degrees of freedom for this test are going to be 2. So from here, we will go into Applia, into the book, and into the statistical tables in Appendix B. I'm going to skip over those steps. I've already done that, and I put that in a PowerPoint slide that I'm going to show you now. So here we have the chi-square distribution. It's table B7, and it's right after Pearson's correlation. In rows, we have degrees of freedom, and in columns, we have alpha levels. One thing you might notice here is that the chi-square distribution is not two-tailed, so we don't have an option for a one-tailed versus a two-tailed alpha level. It's always one-tailed. It actually looks exactly like the F distribution. So we're going to find our degrees of freedom here, 2, and our alpha level of 0.05, and the point where they meet right here is my critical value, 5.99. Okay. Next we do our decision rule. Now because I'm working on a Mac and not a PC, I don't have Paint. So I've already gone ahead and created a decision rule here rather than having you watch me do that. And this is what it would look like if we were to draw the distribution out. You see it looks exactly like the decision rule did with F statistics. Make sure that you label where you would fail to reject and where you would reject, and also label what your critical value is. If you were to write this out in sentence form, and remember, you should only choose one method for writing this, for putting your decision rule. Please do not choose to do sentence form and a distribution. Just pick whichever one you like best and which one, makes sense to you. If my observed, now to get the chi-square test statistic, I'll show you how to do that in a minute. I'm just going to copy and paste it for now from where I have it here. But we will go through how to do that in a minute. If my observed chi-square is greater than 5.99, I will reject the null and conclude there is a relationship between the two variables. Having had a child before or not, and level of postpartum depression. Okay, that's it for my decision rule. Again, You can choose either to write it in sentence form or to draw this distribution, but please don't do both. Moving on, we're ready to do step 4, which is when we collect our data and compute the statistic. So the data have been provided for you in an SPSS file on Canvas. If you haven't opened that, pause the video and open that now. Okay, so here is our SPSS data file. The first variable that we have here is depression status. And if we click on values, you can see we have less depressed, the same, or more depressed. The second variable that we have is whether or not this is your first baby. No for those who have had a child before, and yes for those who have not. They are a first-time mother. All right, so to run our analysis, we're going to go to Analyze, Descriptive Statistics, Crosstabs. That's Analyze, Descriptive Statistics, Crosstabs. And we're going to pop one of our variables over under columns and one over under rows. And it really doesn't matter which goes in rows and which one goes in columns. I'm going to choose to be consistent with the way we had it set up in the example on Canvas, but you don't have to do it that way, and it will make absolutely zero difference in how it turns out. So I'm going to pop over postpartum depression into columns and first baby or not into rows. Next, I'm going to click on statistics. And in this statistics box, I need to tell SPSS to calculate a chi-square. If I don't do this, it'll give me a table that's called a cross-tabulation, and it's basically the same table that we already saw. It's not a whole lot different, and it won't tell us whether there's a statistically significant difference or not. So we need to request a chi-square, and we also want to request our effect size. Now, the two options for effect size when it comes to chi-square are phi and Kramer's V, and the way that SPSS works is you ask for them both at once. You need to know which one is appropriate for your test. So Kramer's V is always appropriate. You can use Kramer's V anytime. Phi can only be used in limited circumstances, and that is when you have a 2x2 matrix. So in this case, we have a 2x3 matrix, 2 rows and 3 columns. So phi is not appropriate for this test. We don't have a way to ask for Kramer's V and not ask for phi, so we're going to get both in our output, but we need to know which one is appropriate to report and which one is not. All right, so I've clicked on statistics, I've chosen chi-square and phi and Kramer's V. Now I'm ready to click continue. Next, I click on the cells box. This is where I'm going to tell SPSS what information to display in that cross tabulation that it's going to provide. Automatically, it's going to display observed frequencies. Those observed frequencies are the actual frequencies of women falling in each of these categories. It's basically the exact same thing that we saw already in our table on SPSS, or in Canvas. We also want it to give us expected frequencies, and those expected frequencies are the frequencies that we would expect under the null hypothesis. So we want to have both, because being able to make that comparison is later going to be able to, or is going to enable us to be able to better understand what's happening with our data. Observed should automatically be checked, but just make sure that it is. Expected will not automatically be checked, so you need to check that. And click continue. That's all I need to do, and now I can click OK and have a look at my output. So the first box that shows up just gives us an idea of our ends and whether we have any missing values. It's not particularly useful. But the next 3 boxes are all going to be a part of our interpretation. I've copied and pasted those into my Word document in order to be able to highlight the parts of it we want to look at. So I'm going to move over into the Word document. Okay, so the first thing that we want to look at is actually the chi-square test, which is the second box down. And we're going to look at our Pearson chi-square, the top row, always. We're never going to worry about these lower rows. In the top row, we have our Pearson chi-square of 9.759, and that's our test statistic. And then we have our significance, our p-value. You'll notice that here it's labeled a little differently than it has been in the other tests that we've done so far in the class. In the other tests we've done so far, this has been labeled as just sig. This time it's called asymptotic significance, and it's interpreted the same way. It doesn't matter at all. So you don't really need to worry about that. We just take that and interpret it as it is. The exact same as we've interpreted before. So if our p-value is greater than alpha, then we would fail to reject the null, and if it's less than alpha, then we would reject the null. So in this case, we have a p-value of 0.08, and we had an alpha of 0.05, so we are going to reject the null. And under symmetric measures, we have our estimates of effect size. We know that phi is not appropriate for this test, so we're going to look at Kramer's V. In this case, they happen to work out to be the same, but that doesn't always work out that way. You'll notice that they have given a significance that's associated with that p-value. You can disregard that. It's not a part of our interpretation. And finally, we come to the cross tabulation, which is actually the first box that SPSS shows. So as you can see, it's fairly similar to what we saw in Canvas, but a little bit more complicated. So let's walk through this actually, because it's going to help us a lot with our interpretation of our results. Here we have the variable first baby, and we have no and yes. Up here is the column for women who have had a baby before. It is not their first baby. Down here is the row for if they have not had a baby before, or if they have not had a baby before, it is their first baby. Each one of those has a count, which is the actual count or observed count, and then the count that we would expect under the null hypothesis if there was no relationship between these two variables. Let's go through cell by cell and compare those observed counts with the expected counts. We're going to use that information later on in our interpretation of the data. So I've already gone ahead and created this little matrix for myself, and I recommend that you do this when you interpret chi-square output because it really helps you make sense of these patterns that we see. So for those women who have had a baby before, this is not their first baby, we have in the less depressed category, we have observed an actual count of 9 women. When we compare that to the expected count of 9.3, they're very similar. There's not much of a difference here. So down here, I'm going to say same as null. Now I'm going to move over to the next box. So for those women whose level of depression did not change after having their baby, and who have had a baby before, it is not their first baby, we have 24 in that category, and we expected to have 19. So there are a few more than what we would expect under the null. So down here, I'm going to say more than null. Finally, for those women who have had a baby before, it is not their first baby, and are more depressed, we have a frequency of 4 observed, and we expected under the null to have 8.6. So we definitely have less than the null, less than what was predicted by the null. Now we're ready to look at those who just had their very first baby. First baby, yes. So for those who fell in the less depressed group, we had 6 women, and we expected to have about 5.8. That's pretty close to the null, so let's say same as null. and for women that just had their first baby, those who fell in the category of having the same amount of depression as they had before having the baby, we actually had 7. We would have expected under the null to have 11.9. So we have less than the null. Now we have, for those women who it is their first baby and they are more depressed now than they were before having that baby, we have an observed count of 10 and an expected count under the null of 5.4. So we definitely have more than expected under the null. We don't need to worry too much about the totals. We have our column totals here and our row totals here. That's just extra information that it is used when we do our hand calculations of chi-square, but it's not used when we do our interpretation of the data. So now we know already, based on our significance of 0.008 being smaller than our alpha level of 0.05, that we will be rejecting the null. We already discussed that. Now we're able to interpret what's going on with this data. So as you can see, in the category of less depressed, the null appears to be true. However, in the categories of same and more depressed, we can see that no, in fact, the null is not true. For those women that have had a baby before, more of them did not get depressed than what we would expect under the null hypothesis, and less of them became more depressed than what we would expect under the null hypothesis. For those women who are having their first or just had their first baby, less of them came out the other side without a change in depression, and more of them came out more depressed than what we would expect under the null hypothesis. So this pattern tells us that those first-time mothers definitely are experiencing more depression. And another way to think about that is that there is a relationship between having had children before or not and the level of depression that you experience postpartum. So now we're ready to report the results in standard format. The first thing I'm going to do is show you how to get that symbol that we use for the notation for chi-square. You're going to go to the font menu in Word, and you're going to select symbol from your list of fonts. Once you've selected that, you're going to type the letter C. The letter C in the English alphabet corresponds with the letter chi in the Greek alphabet, and the letter chi in the Greek alphabet looks like an X, but kind of curly. Once you've got that chi in your document, you can go back to your font browser and change it back to whatever font you prefer or whichever font you are using. Now we need to give it that squared symbol. And to do that, we're going to click on the superscript button, which falls right below the font size buttons, and type a 2. And after we've typed that 2, we're going to click that button again to get rid of the superscript effect. Make a space, and now we're going to put our parentheses in. In those parentheses for the chi-square test, it's a little bit different than what we've seen so far. We include our degrees of freedom of 2, but we also include our sample size. So we're going to put in our degrees of freedom, then a comma, then our n equals, in this study we had 60 total, and what we're listing is the total n. So we have n equals 60, and close the parentheses. Now we're going to type in our actual chi-square. So let's go back and look at our SPSS output and get that exact chi-square. So our exact chi-square here is 9.759. The next thing that's part of our standard format for chi-square is our p-value or significance. If you were calculating by hand, you could just say p is greater than 0.05 or p is less than 0.05, depending on the comparison between your critical value and your observed chi-square. But in our case, SPSS gave us an exact p-value that's associated with our exact chi-square. So we're just going to enter that exact p-value. Looking back at our output, there it is, that asymptotic significance, 0.008. The last thing we need to include is our effect size, Kramer's V. And looking back at our output, Kramer's V was 0.403. That's it for reporting in standard format. Now we're ready to state our decision and interpret our effect size. So the first step of stating our decision is to say whether we reject or fail to reject the null. We've already decided that we will reject the null. The reason we'll reject the null is because this chi-square value of 9.759 is definitely larger than our critical value of 5.99, and our p-value of 0.008 is definitely smaller than alpha. So this is a situation in which we would reject the null. When it comes to chi-square, rejecting the null lets us know that there is a significant relationship between our two variables. So similar to when we do a correlation, we're talking about relationships rather than differences. So I reject the null and conclude there is a significant relationship between whether this is a woman's first baby or not, and her level of postpartum depression. Now we need to turn to that cross-tabulation to talk about where those differences lie. So thinking back to when we set up this matrix and interpreted that, remember that we concluded that women who were having their first baby or had just had their first baby were experiencing more depression. So I said, women who have not had a baby before experience more postpartum depression than experienced mothers. The last thing that remains is that we need to interpret our effect size, Kramer's V. Now, if you'll think back to lecture in class, when you interpret Kramer's V, the guidelines that we use to decide whether it's small, medium, or large vary depending on your degrees of freedom. So let's go into the slides and have a look at the guidelines that we use, and keeping in mind that the Kramer's V that we obtained was 0.403. So here's a slide from class, and I have gone through and selected the line that says degrees of freedom 2 because we had degrees of freedom 2 in this case. And I've bolded that, made the font bigger, and put it in red so that it really stands out. So the guidelines that we're going to be using are the ones in red because we have a degrees of freedom of 2. The cutoff for being a large effect size is 0.35, for a medium is 0.21, and small is 0.07. Clearly, our Kramer's V of 0.403 is well above the cutoff of 0.35, so that suggests that we have a large effect size. So now we need to interpret that large effect size. And remember, effect size does not refer to significance, it always refers to meaningfulness. And in chi-square, since we're talking about a relationship, that effect size says that the relationship between these two variables is meaningful. That's all for step 5. For step 6, we are ready to come up with ideas about improving on this study, talk about the limitations, talk about the weaknesses, or we can talk about the implications. What does this study mean for society? Why would we care about this result? Or we can talk about ideas for future studies. What about looking at the impact of age? So for future studies, the impact of age on mothers' levels of depression should be explored. Another example could be to say future studies should examine whether there are differences in depression based on whether a mother is partnered or not. So you can come up with your own ideas. These are just a couple of examples. That's it for SPSS 10 chi-square, and you've now finished your last SPSS lab for the class.